Hey y'all, in this video we're going to go over the graphing motion notes on acceleration time graphs. And these will be pretty short because the graphs are pretty easy. So acceleration time graphs are graphs that represent the acceleration of the object over a set amount of time. For these graphs, we are going to keep it very simple. The slope on these graphs is always going to be 0. So you will just see horizontal lines. It's just a matter of where along the y-axis those horizontal lines are placed. The x-axis is going to represent an acceleration of 0. So an acceleration of 0 means the object could either be not moving or moving with a constant velocity. It could be either of those things. So for instance, on this example graph here, from 0 to 2 seconds, we do have an acceleration of 0, but we don't know enough information just based on that as to say it's just stopped completely, which you wouldn't have any acceleration when you're stopped, or it could be keeping a constant velocity. For instance, it could be going 5 meters per second, and that means it has no acceleration as well. Then we see from 2 to 4, we have a line above the x-axis. So if these go up by 1 to 2, so this would be 3 meters per second squared for the acceleration. So then if we're accelerating, we definitely have to be moving, all right? And we are, of course, moving here with a positive acceleration, all right? We can use the area to find out information. We won't be dealing with slope because slope is always going to be 0 for these. But the area is going to tell us the velocity. So it could either be a negative area or a positive area. A negative area would imply that we have a negative velocity. Positive area would mean we have a positive velocity. So if we found the area of this box here, that would tell us the velocity for that time period. All right, so let's see what you understand so far. So during which time segments on this graph is our object, does it have a negative velocity? Right? If you said from 4 to 6 seconds, you would be correct because that's where our horizontal line is underneath our x-axis. Right? For number 2, no acceleration. Of course, that's going to be when our line is on the x-axis, which is 2 to 4 seconds. And then for number 3, positive velocity would mean when it has a positive area, so it would have to be from 0 to 2 seconds, in which case we would have a positive area here, right? For question 4, what is the velocity between 0 to 2 seconds? So we would need to find the area there. So we have a width of 2 and a height of 2, so 2 times 2 is 4, so our velocity is 4 meters per second. All right, and last question, we're going to bring in position graphs and velocity graphs. So for each of the following graphs, determine the following. First, the type of graph, then if there's motion or not, and if there's acceleration or not. So this first graph here, we have an X here. We use X to represent position graphs. We have a diagonal line, and on a diagonal line on a position graph does mean we have movement. It is moving with a constant velocity. So for question 3, does it have acceleration? The answer would be no. So we have a position graph with movement and no acceleration. We're going to consider this one right here, the second graph on the top right. So we have a velocity graph designated by this V here. Is there motion? We have a diagonal line on a velocity graph, which does imply there is motion, and it does mean it's accelerating. So we have a velocity graph with motion and acceleration. For the third one, we also have a velocity graph. This time we have a horizontal line that is not on our x-axis. So the object is moving. It's just doing this at a constant velocity, meaning there is no acceleration. Then the last one, we have an acceleration graph designated by this A here, and it is moving and does have acceleration because we have a horizontal line above our x-axis. It would be possibly not moving or have no acceleration if it was on the x-axis. So we have an acceleration graph with movement and acceleration. Right. Well, that's it for the acceleration time graph notes. If you have any questions, please reach out to me.